And here we go again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Just a reminder, a couple of things. So I sent out the chapter 14 PDF yesterday, so you should be able to reference that today if you need it for extra help with your assignment. If you did not get, well, be sure and check your email. If you didn't get it, email me back, say, hey, I didn't get it, and I will send it again to you. Okay. So I've got some requests from a student or a couple of students to do some problems. So we're going to take a look at those. Here's the first one. These are all out of section 4.5. This is problem number 10. And here we have a system of linear inequalities. And so we're going to use the same basic steps that we used back in 3.7. I'm going to take this first, the black inequality, and I'm going to rewrite its equivalent equation, so to speak, or its related equation. So, oops. So we've got 3x plus 2y minus 10 equals 0. Okay, we're dealing with just the equals part. And now I'm going to make a table. I don't have to, but I'm going to continue to use the x and y intercepts just because they're easy values to use. So first of all, if y is 0, we get 3x plus 2 times 0 minus 10 equals 0, which becomes 3x plus 0 minus 10 equals 0, which becomes 3x minus 10 equals 0. By adding 10 to both sides of the equation, we get 3x equals 10. Dividing both sides by 3, we get x equals 10 thirds. Okay. Next, let x equal 0. We get 3 times 0 plus 2y minus 10 equals 0. 3 times 0 is 0. 0 plus 2y minus 10 equals 0. 0 plus 2y minus 10 is 2y minus 10. So 2y minus 10 equals 0. Add 10 to both sides. 2y equals 10. Divide both sides by 2. Y equals 5. Okay, so we now have two ordered pairs that represent points on the line created by this equation. Okay, but in fact, we're dealing with this situation since it's greater than or equal to, because it does include the equals to. We're going to graph a solid line, not a dashed line. Okay, so I come over here to the graph and I click on that until it's blue. Again, I want the line, not the ray or the line segment, but the line. Now, 10 thirds. 10 thirds, if I change that to a mixed number, I get 3 1/3, which means it's going to be slightly larger than 3. But let's see. Oh, look here. This particular grid that I chose, and this may not be the one that you had on your problem, but the scale is that each square is 2 units. So 3 1/3 would be right about there. Okay. So 3 1/3, 0, and then 0, 5. Now, I already mentioned that it needed to be a solid line. Let's go up here and let's make sure. Oh, look at that. 10 thirds became 3. Now, as I mentioned yesterday, you don't want to use a mixed number because it doesn't interpret it correctly. And you don't want to round off and say, oh, it's 3.3. It's 3.3 repeating. So the best way, the easiest way to get the right numbers in there is to use the fraction form. So now my first point is 10 thirds 0. My second point is 0, 5. Any questions so far? All right. So now I need to determine which side of this line is the greater than part. Okay. So I'm going to pick a test point. So let's see here. Test point. I need to pick something that is not on the line. So again, I'm going to go with 0, 0. Now, the test point goes into the inequality. We only use the equation to establish the points. Okay. All right. If I put x is 0 and y is 0 into this linear inequality, I get 3 times 0 plus 2 times 0 minus 10 greater than or equal to 0. 0 plus 0 minus 10 greater than 0. Negative 10 greater than or equal to 0. That is false. So this is not a good test point. So since this one doesn't work, this side of the line is where we're going to fill it. Okay. So if all we were doing was the black inequality, this would be the solution, but we're not done. What I'm going to do now is I'm going to draw a little sketch here to remind me of what happens with that first inequality. Okay. So now I'm going to go back and I'm going to deal with the red inequality. So I'm going to create the related equation, x equals -1 plus y. Okay. And I'll make a table. Whoops. And find the x and y intercepts. If y is 0, x equals -1 plus 0, x equals -1. If x is 0, 0 equals -1 plus y, add 1 to both sides, and y equals 1. Okay. So now I come back over here and notice that my shading has disappeared, which is why I made a note to myself there. Okay. So -1, 0, and again, the scale is each square is 2. So -1, 0 would be about there, and 0, 1 would be about there. I'm going to go in and check. Yes, my points are correct, but oh, this inequality does not include the equals, so it needs to be a dashed line. Okay, not a solid line. Again, if it includes equals, it's solid. If it doesn't, it's dashed. All right, now I need to decide which side of this line, the dashed line, am I going to shade? Well, again, 0, 0 is a good test point because it's not on the dashed line. So we've got test point 0, 0. That's going to go into this inequality. 0 less than -1 plus 0, 0 less than -1, that is false. Okay. So for the dashed line, 0, 0 is not a correct point or a part of the solution. So we go to the other side. So we're going to fill it over here. Okay. And again, I'm going to draw a picture, oops, to remind me of what it looks like. Okay. So now if I take this black drawing and this red drawing and put them together, where would they overlap? Okay, so again, the black drawing would overlap, would have these two pieces. Okay, the red drawing would have those two pieces. So where do they overlap? Right here. So there is the complete solution. I've got a solid line for this first inequality, a dashed line for the second inequality. The shading where they overlap is up in this area. So the solution is this piece right here. And again, it extends beyond the what you can see there, but there you have it. Oops. So any questions about this particular problem? All right, then we're going to start over. So we'll clear that one. And we're going to look at another problem. Let's see here. Make sure I've got the black color there. So we've got 2x minus 3y less than 0. I'm going to write the equation related to it. So that would be 2x minus 3y equals 0. And I'm going to make a table and look for the x and y intercepts. Okay, so if y is 0, I get 2x minus 3 times 0 equals 0. 2x minus 0 equals 0. 2x equals 0, divide both sides by 2, and x equals 0. So what we have here, this inequality goes through the origin. So I'm going to have to use a different value to find my second point, because if x is 0, y is 0. If y is 0, x is 0. Well, let's just go ahead and use 1. Okay, so if x is 1, 2 times 1 minus 3y equals 0. 2 minus 3y equals 0. I'll go ahead and add 3y to both sides. 2 equals 3y. Divide both sides by 3. And 2/3 equals y, or y equals 2/3. We'll just block that out. So now I have two ordered pairs, 0, 0, and 1, 2/3. Any questions about this? Okay, so I come over here and click on the line until it turns blue. Again, my scale is in 2s, so 0, 0 is right there. And 1 2/3 is about there. And I say about because I'm not concerned about accuracy, because I'm going to go over here and fix it. Okay, so back over here. Now, but this doesn't include equals, so it's going to be a dashed line. Okay, but also, let's see, 0, 0 is correct. 1, oh, this value, y value, needs to be 2/3. So I've fixed it over here. So there's my first inequality. All right, now I need to choose a test point on one side of the line or the other. Since this goes through 0, 0, I can't use that as a test point. Oh, how about let's use 14, 2. Okay, 14, 2. So test point 14, 2. So that's going to go into that inequality. 2 times 14 minus 3 times 2 less than 0. 28 minus 6 less than 0. 22 less than 0. That is false. So our test point, 14, 2, is incorrect, which means we aren't going to shade this side of the line. It's going to be on the above side. Okay, so I'm going to fill it in there. And again, I'm going to draw a picture here to remind me. So I've got a dashed line and it's filled in above it. Any questions? All right, let's continue on. And let's take a look at the red inequality. There we go. So I'm going to take the inequality and write the related equation. I'm going to make a table and use x and y intercepts if they work out. Okay, if y is 0, I get 2x plus 3 times 0 equals 15, which is 2x plus 0 is 15. 2x equals 15. Divide by 2, x equals 15 halves. Starting over, if x is 0, 2 times 0 plus 3y equals 15. 2 times 0 is 0. 0 plus 3y is 15. 0 plus 3y is 3y. 3y equals 15. Divide both sides by 3, and y equals 5. So once again, I've got 2 points. I'm going to come over here. And again, the shading disappears, which is why I left myself a note there as to what's going to happen. 15 halves would be 7.5. So 7.5, 0 is going to be right about there. Again, I'm not concerned about it being perfect because I'm going to fix it in a minute. And then 0.5 would be right there. Okay. This includes the equals in the original part. So it's going to be a solid line. All right, so this needs to be 15 halves, 0, and 0.5. Okay, now the solid line, I can use 0, 0 as a test point because it's not on the solid line. Okay, so we'll go, let's see, test point.
Mayo, I have a question.
Yes.
So you know how you got 15 thirds? Is that what you put in the graph, like 15/3?
Right here? Or are you talking about this?
No, on the graph. Like on line 1, do you put 15/3, like so the point could graph?
Okay, hold on. You said line 1. Line 1 was this dotted line here. Is that the one you want?
No, I mean line 2 on.
Okay, line 2. Now, do you mean 15 halves?
Yeah.
Okay, so go ahead and ask the question again. What about 15 halves?
Because you know how you got 15/3 on the red
Over
right
here?
Yeah, right there.
Yeah.
So you would put 15/3 on the graph, or you would put 15/2.
Okay, okay. This was solving for y. 15/3 reduces down to 5, which is right there. So I think you're confusing this number with that number, and they aren't the same. This number led to the 5.
Oh, wait, yeah, I'm confusing the numbers.
Okay.
I'm confused on the 15/2, like.
How I got that?
No, so like, would you put that on the graph, like 15/2, or would?
Yes, it's right there.
Oh, okay.
You seeing that?
Yeah, I was just confused. Never mind.
Okay, yeah, and again, what I did when I went to plot this point, and I clicked on it, it actually took it. It always seems to take it to the nearest integer, so it took it to a 7. So that's why I had to come in here and fix it. Okay. You all right with that? Or
Yeah.
Okay, okay. So let's see. Oh, we were going to do a test point for the solid line, and I said we could use 0, 0. So that's going to go in here, which is going to give us 2 times 0 plus 3 times 0 greater than or equal to 15. 0 plus 0 greater than or equal to 15. 0 greater than or equal to 15 is false. So for the solid line, 0, 0 is not a correct test point. So it's going to be up here above. So for the red graph, it's going to look like that. Okay. So again, let's go back, kind of review here. For the black line, it's a dashed line because it doesn't include equals. And the test point was no good. So it turned out that we were going to fill it here and here. For the red line, we were going to fill it there and there. So where did they overlap? Right there. So that would be the final solution. This line is solid, this line is dashed, and this area up here should be shaded in. Are we okay with that? All right, I'll take that as a yes. And we've got one more example here. So let's see here. I need to make this back to the black ink. Y plus 2x less than or equal to 0. Okay, that would be related equation y plus 2x equals 0. Okay, I'm going to let y equal 0. When y is 0, I get 0 plus 2x equals 0. 0 plus 2x is just 2x. 2x equals 0, divide by 2x equals 0. So this graph again goes through the origin, so I can't use both intercepts. And I'll go ahead and just use a 1 again there. So x plus 2 times 1 equals 0. Excuse me, y plus 2 times 1 equals 0. Y plus 2 equals 0. Subtract 2. Y equals -2. So here's our two ordered pairs. 0, 0, and 1, negative 2. Okay, now this includes equals, so it's going to be solid. Oh, I didn't get negative 2, did I? But I've got 0, 0, 1, comma, negative 2. I can't use 0, 0 as a test point because the graph goes through 0, 0. How about let's go 6, 6. Okay. So the test point, 6, 6. We're going to put that into the original inequality. 6 plus 2 times 6 less than or equal to 0. 6 plus 12 less than or equal to 0. 18 less than or equal to 0. That is false. So that means the point 6, 6 is not part of the solution. So we're going to fill on the other side of the line. Okay. And again, I'm going to draw a map to remind me of what it looks like. All right. So there's the black inequality. Any questions there? Let's take a look at the red. So I'm going to look at the equation y equals 1/2 x plus 2. And I'm going to go with x and y intercepts again. If y is 0, 0 equals 1/2 x plus 2. Let's see, I'm going to subtract 2 from both sides. Negative 2 equals 1/2 x. Do you remember when you have a coefficient of a variable, the number in front that tells you how much of that variable you've got, so in this case, 1/2. If the coefficient is a fraction, you multiply both sides by the reciprocal, which would be 2 over 1, or just 2. So then you get x equals negative 4, comma 0 for the complete ordered pair. All right. If x is 0, y equals 1/2 times 0 plus 2, y equals 0 plus 2, y equals 2. So we've got negative 4, 0, and 0, 2. Okay. Negative 4, 0, 0, 2. This one also has the equals part of it, so it's also solid. I could use 0, 0 as a test point for this line, so I will. Okay, so let's see. Test point 0, 0. We'll plug that in there. So we get what? 0 less than or equal to 1/2 times 0 plus 2. 0 less than or equal to 2. That's true. So for this second line here, the one that's from the red inequality, 0, 0 is a true solution. So down here. Okay. So going back, this first line that's x plus 2, or excuse me, y plus 2x less than or equal to 0 would be shaded here and here. The second line, y less than or equal to 1/2 x plus 2 would be shaded here and here. So where do they overlap? Right there. So there's your final solution. Both lines are solid in this case because both inequalities include equals right here and right here. And this is the shading that overlaps. Any questions on that one? Okay. Then we're going to go on. And so, let's see here. Can you? Yes. What?
Mr. Mayo, I'll be leaving 5 minutes early today because my brother has a clinic appointment.
Okay.
So I'll be leaving around 11:15.
Okay. Thanks for letting me know. That's fine. You can catch the rest of it on, well, on the recording. We might even be done by then. We'll see. Okay. Give me just a second here. I think what I'm going to do is switch back to this screen because I'm going to look at some stuff on the internet as well. Okay. So can everybody see my whiteboard screen now? Somebody?
Yes.
Thank you. All right. I mentioned, I believe it was in the syllabus, about where to find a calculator, okay? And so what I want to do is remind you of how, or show you how you do that. Basically, go into onto a web browser and type in scientific calculator. I didn't, let's see. I didn't spell it right, but you know what? It came out. And when you do that, you should get this calculator, all right? Now, this calculator, there's a symbol right there it's an X with an exclamation mark, okay? And we're going to come back to that in a little bit, but that's going to be significant. That's what we're going to be doing in this section, using that. So let's go back to just the regular, or just my whiteboard screen, okay? So how did I get it? I just typed in scientific calculator. Now, today we're going to look at something called factorials, okay? Factorials. Why are we even studying this? Well, some of you are going to be going on and taking statistics. Some of you are going to be going on and taking Math 107. And in both those classes, you deal with some things to do with statistics and probability and the odds of things. And there are formulas in these courses that involve factorials. So we need to become familiar with them. So that's the main reason we're going to be studying them this quarter. All right, now, a factorial has the following notation. There's a number and it's followed by an exclamation mark. So basically that means 4 factorial. Now, how do we interpret that? 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is 24. So 4 factorial equals 24. What about 6 factorial? 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30. So that's 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. And 720 times 1 is 720. Also, 0 factorial by definition equals 1. Even though 0 times itself is not 1, this is just a special case, okay? So 0 factorial equals 1. 4 factorial is 4 times 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, okay? Now, let's go back to the calculator screen. And for instance, let's find 4 factorial. So 4 factorial is 24, just like I said, okay? And then we'll clear it and we'll say, what was it, 6? 6 factorial is 720, okay? So you put the number in, then you click the button to put the factorial behind it, and then you push equals. Any questions about that example? Okay, now, if you have the calculator that's recommended for this class, which looks like this, the TI-30X Roman numeral 2, on this calculator, the factorial button, let's see, it's, okay. Let me see here. So you'd start out by turning the calculator on, okay? There is a button that says PRB. It's right there. If I push that button, a menu pops up, and I don't know if you can see this, But you see the third thing over is an exclamation mark. So that's factorial. So let's say I want to do 4 factorial. Okay. Calculator's on, but it's cleared. I push the number 4. I know this is kind of weird looking at it this way. Then I push the PRB button. Okay. I use the right arrow to scroll over so that the factorial button is highlighted. I push enter, the equal sign, and I get 4 factorial. Then I push equals again, and I get my answer of 24. Okay, and I know that's not a very efficient way to do it, but I haven't figured out yet how to do it any other way displaying this particular calculator. And you don't have to use this scientific one. You can use any scientific calculator you want, or you can use this online calculator if that's easier to use. Okay, any questions at this point? All right, now we're going to play with these factorials to show some just kind of how they work. Let's say I've got 3 factorial plus 4 factorial. Well, 3 factorial is 3 times 2 times 1, and 4 factorial is 4 times 3 times 2 times 1. 3 times 2 times 1 is 6. 4 times 3 is 12, times 2 is 24, times 1 is 24. 6 plus 24 is 30. Okay. Any questions about that example? All right. How about this one? 2 factorial times 3 factorial. Well, 2 factorial is 2 times 1, and 3 factorial is 3 times 2 times 1. Okay. 2 times 1 is 2. 3 times 2 is 6, times 2 is 6. 2 times 6 is... Yeah.
Your screen's still on the calculator, so I can't see what.
Thank you. Yes. That's why I told you guys, if you can't see what I'm doing, remind me, because sometimes I forget. Can you see it now?
Yes, thank you.
Yeah. So now all that stuff that I did, nobody could follow. Just jump in there right away and say, hey, you got the wrong screen. Okay. Do I need to go back and go over this problem? Anybody?
Yeah, please.
Yeah, okay. So it was 3 factorial plus 4 factorial. So 3 factorial is 3 plus, times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 3 times 2 times 1 is 6. 4 times 3 times 2 times 1 is 24. 6 plus 24 is 30. And these little x's, that's multiplication. That's not a variable. Are you okay with that one? Hello?
We are okay with it.
Thank you. And then here, 2 factorial times 3 factorial. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. Then you get 2 times 6, which is 12. Okay? All right. Now, what about this one? 49 factorial over 47 factorial. Well, if we do this the long way, this is going to be horrible. The long way would be, oh, this is 49 times 48 times 47 times 46, on and on and on and on, all over 47 times 46 times 45, on and on and on. But wait a minute. Wouldn't the 47s and the 46s and the 45s, wouldn't all of that just reduce down? So all we'd have left would be 49 times 48. Yes, it would. So here's what I can do. In fact, I'm going to back up for a minute, and then we'll come back to that problem. Let's go back here. 10 factorial would be equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Everybody said, right, okay. But 10 factorial would also be 10 times 9 factorial, because isn't that 9 factorial? Or we could say 10 factorial is equal to 10 times 9 times 8 factorial, because 8 factorial would be equal to that. Are you seeing what I'm showing you here? Are you following that?
We're following.
Excellent. Okay, so now I could take 49 factorial over 47 factorial, And on top, write 49 times 48 times 47 factorial all over 47 factorial. So basically what I did up here, but without expanding it beyond. Okay, see how I got that?
Yes.
Yes.
This reduces to 1 over 1. So now I've basically got 49 times 48. And on my calculator, I go 49 times 48. It helps if it's on 49 times 48. And I get 2,352, which is much easier than doing this the long way. Okay. You all right with that? Let's take a look at
Yes,
another. Okay, another. I'll assume if nobody says, wait, I don't get it, I'll just keep going so you don't have to keep responding. Yeah, we get it, we get it. Okay. All right, how about this one? 13 factorial over 10 factorial. So I'm going to take 13 factorial and write it as 13 times 12 times 11 times 10 factorial over 10 factorial. So basically I'm taking that and pulling that out of it so that I can come in and reduce those to 1 over 1. So all I've got left is 13 times 12 times 11. And let's see what that is. 13 times 12 times 11 is 1,716. Okay with that?
So when you do the 13 and 12, you don't put the factorial only when it's 11.
You mean here?
Yeah, like that's when you only put the factorial, right?
Well, I've gotten rid of the factorials because the 10 factorials reduced down to 1 over 1. So
Okay.
from here on out, there's no factorials.
So then you just multiply those?
Sorry?
So you just multiply those?
Yes, what's left?
Okay,
Does that make sense?
kind of, yeah.
Okay, well, let's just forget factorials for a moment. Let's say I've got this. Okay, let's say I've got 2 times 3 times 5 times 7 over 5 times 7. You could say 5 over 5 reduces down to 1 over 1. 7 over 7 reduces down to 1 over 1. And basically I've got what 2 times 3 is 6 times 1 is 6 over 1 is still 6. So I'm just going to get that.
Okay.
So same thing applies here. Let's see what, let's write this out again. I've got this over that, and I take 13 factorial and I break it down so that I pull out the 10 factorial. Those reduce down to 1 over 1.
Mhm.
And all I've got left now is that, which was what, 1716. Does that
Yeah,
make sense? Okay.
yeah.
excellent.
Mr. Mayor,
Yeah, what?
how do you know how many times you go down? Like it's 13, 12, 11, 10. It's 4 times, but how do you like know?
Okay, it's not, you're right, it's 4 times, but that's not what's important. What's important is this. That tells me where to stop
Oh, so the number on bottom is where you stop.
because you want to match them so you can get rid of the bottom number.
Oh, okay.
Let's do a different one. Let's say we have 13 factorial over 9 factorial. Then I would do this. I would take it all the way down to 9 factorial so that I could get rid of it. And then I'd multiply all that together. Is that making sense?
Yeah.
So the idea is to wipe out that. So I got to expand that to where I can get it to there. Or here's another example. Oops. Let's say I've got 13
Is it
factorial.
basically like combining like terms?
No, combining like terms would imply addition or subtraction, and this is all multiplication and division. We're matching like factors. I know what you mean by saying combining like terms, but that's not quite the correct notation. We're matching like factors so that we can divide out. Does that make
So
sense?
that
What?
so the 9s cross out, and then so we would just have to multiply the 13, 12, 11, and the 10.
Yeah.
And that's how we get our answer.
Yeah, let's take a look at this one. So here, I'm going to expand this down to where I've got 11 factorial so that I can reduce those down. And then I'm just going to take 13 times 12, which is what, 156, I think. Okay with that?
Yes, it makes sense.
Okay. Now we're going to wander into the deep end. So get your life jackets on. 15 factorial over 14 factorial times 15 minus 14 factorial. Okay. Now, order of operations. What I'm going to do, first of all, is I'm going to do what's in the grouping symbol. What's 15 minus 14?
1.
So this is 1 factorial. Okay. Now, I'm going to focus on this. 15 factorial is equal to 15 times 14 factorial. Why did I stop expanding it there? Why didn't I go 15 times 14 times 13 times 12 times 11? Because now these two will reduce out. So what do I have left? I've got 15 over 1 factorial, which is just 1, and 15 over 1 is 15. So this whole mess is just 15. But I got rid of all of this part of it by reducing it out with that. So the idea is to get a match, get a factorial on top and divided by a factorial on the bottom. And if they match, you can reduce them down to 1. And there was silence. How are we doing?
I understand it.
Okay, let's take another one. Okay, 5 factorial over 3 factorial times the quantity 5 minus 3 factorial. So this is 5 factorial over 3 factorial. What's 5 minus 3?
2.
2 over 2 factorial. Okay. So I'm going to take 5 factorial and use it to knock out that. So 5 times 4 times 3 factorial over 3 factorial times 2 factorial. Okay. So now I can get rid of the 3 factorials. They're reduced down. So let's see, 5 times 4 is 20. 2 factorial is 2 times 1. So that's 20 over 2, which is 10. We're good to go on to another example, or do you have any questions there?
How did you get the, oh, wait, no, never mind. Wait, no, how did you get the 1 on the
Wait.
2 plus?
Right here?
Yeah.
That's 2. Okay, so 2 factorial is 2 times 1. Maybe it's hard to read that. This was 20, which was from here. And then down here, this is 2 times 1, because 2 factorial is 2 times 1.
Oh, okay, yeah.
And then that's equal to 2, and 20 divided by 2 is 10. Okay,
And a quick question, to clarify, you wouldn't continue the 5 factorial down to like going to 2 factorial and canceling them out into 1? Or what, is it completely separate?
okay, if I'm understanding, you're saying, can we use it to deal with that?
Yes.
We could do that instead, and that would look like this. But wouldn't it be better to knock out the bigger one?
Yes, okay, that makes sense now.
Yeah, so if you were thinking, well, I can use it to knock out the 3 factorial and then go back, well, after I've gotten rid of the 3 factorial, I just have that on top. I don't have 5 factorial. I've messed it up. So yeah, so I would go for the bigger one. You could do the smaller one instead, and then you'd come back and say, well, what am I going to do now? I've got 5 times 4 times 3 over 3 times 2 times 1, et cetera, et cetera. It works, but it's going to be more work. So my goal is always knock out the biggest ones you can, just to make it less work. Okay, how about this one?
I'm gonna have to go right now. Bye, Mr. Mayo.
Okay, take care. So we've got 6 factorial over 4 factorial times the quantity 6 minus 4 factorial. Did I redo that one? I don't think so. Okay. All right. So this is 6 factorial over 4 factorial times 2 factorial, because 6 minus 4 is 2, order of operations. So now here again, I could knock out the 4 factorial in the denominator or the 2 factorial. I would go with the 4 factorial because that's going to make things smaller quicker. So I would write that on top so that I can get rid of the 4 factorial. Okay. And then I'm going to, let's see, so that's going to be 1 over 1. So now I've got what, 30 on top. 2 factorial on the bottom is 2 times 1. So that's 30 over 2, which is 15. If instead I wrote, if I did it this way, and chose to get rid of that, now I've got a bigger number to still deal with. So you see the advantage of getting rid of the biggest factorials that you can.
Yes.
Okay, it's not that it's wrong doing it the other way, it's just extra work. Okay. All right. This one. 6 factorial times 7 factorial over 8 minus 3 factorial times 7 minus 4 factorial. Okay. So this is 6 factorial times 7 factorial over 8 minus 3 is 5 factorial times 7 minus 4 is 3 factorial. Okay, so what I'm going to do now, I'm going to use one of the ones on top to knock out one of the ones on the bottom, and the other one on top to knock out the other one on the bottom. So watch closely. I'm going to put these together, and then I'm going to put those together, so to speak. So 6 factorial over 5 factorial would be 6 times 5 factorial over 5 factorial, okay? 7 factorial over 3 factorial is going to be 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. So what that allows me to do is get rid of the 5 factorials and the 3 factorials. So on top, I've got 6 times 7 times 6 times 5 times 4 on the bottom times 1. Now, there's still a lot left on top, but you can't always knock everything out. So this is going to be, let's see here, 6 times 7 times 6 times 5 times 4 is 5,040 over 1, which is just 5,040. Now, could I instead have done these two together and then those two together? Yes, absolutely. You need something on top that's bigger than something on the bottom to wipe out what's on the bottom in terms of factorials. Okay. All right. We're almost out of time, so I just want to do one more thing. And this is a problem where you're definitely going to want to use a calculator. For instance, it says 13 factorial. Okay. So I can, I'm going to go back and show the calculator screen. And we'll clear that answer. So 13 factorial is, wow, let's see, what is that? That's 6,227,020,800. Okay. Let's do another one that's even larger. Let's do this one, 55 factorial. Now, what does this mean? How do you interpret this? So this E plus 73 is basically saying scientific notation times 10 to the 73rd power. So 1.2696403 E plus 73, okay, that is 1.2696403 times 10 to the 73rd power. So even though the calculator shows that, you don't want to write that. You need to write it like this. Okay. All right, I will be back today at 1:15 with an office hour. So if you've got questions and want to come then, otherwise I'll be back tomorrow morning at 10:30. So I'm going to go ahead and stop the recording.